Okay, so Mars is 1.524 astronomical units from the sun, right? What does that mean? Well, that means that it is 1.524 times as far as we are from the sun. And the interesting thing is that back in this day, back in like Kepler and Brahe's day, they didn't actually know how far away the sun was in feet or inches. But they had a pretty good idea that if we were one astronomical unit from the sun, that Mars was, well, 1.5247, like on the average, right? They had a pretty good idea of the relative distances to the sun, but they didn't have the actual distance in like meters, which is sort of kind of historically important, but maybe you don't think it's that important, right? So we're going to make this be Mars, right? This is Mars, will be the number 1, right? And then number 2 will be Earth. Earth! All right, wow, help. Let's try it again. There, Earth. That'll be our situation, our second one, right? So we'll go R of Mars to the third over the period. Oh, shoot. Okay, so we'll go 1.524 to the third divided by the period, Mars's period, right? Squared, and that equals our information. So 1.000 to the third divided by 365.26 squared. All right, here we go. Okay, are we ready? Or is it 1.365.24? I really don't know. Should look that up. All right, so here we go. So I'm going to go, I guess I'm going to go this guy, 1.524 raised to the third. And then I'm going to multiply by this guy, 365.26 squared. Then I'm going to divide by 1 to the third. All right. And this will give me the period squared, so now I need to take the square root of that. And I get that the period of Mars's orbit is 687.2 days, sorry. Notice that here I'm using astronomical units, and that is AUs, so that those units match. Here I used years, and so I'm going to get Mars's period in years. So you can use cubits or whatever you want, but it has to be the same on this side as this side. And then whatever unit you use for this, you'll get the unknown will be in that unit. So that's good to know.